Good morning, everyone. How are you all? Fine. After a gap of a week, we are once again back, dear friends. I'm very happy to be with you all. As promised, we are again fresh, energetic. So let us revise a few things that we had in the last week. You may be having some problems related to atomic structure, but as I said, dear friends, kindly keep all your doubts written somewhere because many a times we forget such things. Many a times we forget our doubts. So what you have to do is you have to keep the doubts recorded in your notebook, chemistry notebook. So that will be helpful for you all. And we can use it during the doubt clearing session. If you have a doubt, kindly keep it so that it can be cleared out during the doubt clearing session, or else you can personally message me as like some of the students did. No problem. So before we move towards today's topic, let us see something that we have seen in the last week about the atomic structure. Let us revise shortly a little bit of that. So, in case of atom, matter is made up of smallest particle called as the atom. In this study of atom, we have seen the Dalton's atomic theory where Dalton said that matter is made up of very small tiny neutral particles called as the atom. Some of the points of this Dalton's atomic theory, let us see some of them, that these atoms are indivisible. You cannot create atoms, you cannot destroy them. Then atoms of the same element or atoms of an element, all the atoms of an element are identical with respect to mass and properties. They combine in a simple whole ratio or a whole number ratio. These were few things. After that, we saw the discharge tube made up of glass. The end connected to the negative plate is called as the cathode, and the end connected to the positive terminal of the battery is called as the anode. Now the discharge tube works under a very low pressure. That means you are removing out the vacuum from it. You are taking out the vacuum from it. This was the discharge tube. And this discharge tube was used for the discovery of electrons by Sir J.J. Thomson. By Sir J.J. Thomson in 1897. So that means who discovered the electrons? Sir J.J. Thomson. What Sir J.J. Thomson did? He took the discharge tube. He took the discharge tube and he found that when the discharge tube was in a working condition, from the cathode, the rays were emitted and they traveled towards the anode. And now he just adjusted this tube with a positive plate and a negative plate. He supported it with a positive and a negative plate. And he found that when the rays, these cathode rays, then when they were traveling straight, when the cathode rays were traveling straight, they were attracted towards the positive plate. The cathode rays, that means the negative plates, they were attracted towards the positive plate, indicating that these cathode rays are negatively charged particles called as the electrons. He named them as electrons. So in this way, the electrons were discovered. We also saw the discovery of nucleus by Rutherford. What Sir Rutherford did? He took a gold foil and he bombarded it with the alpha particles. He bombarded it with the alpha particles, and as you can see in the picture, it was clear that most of the alpha particles they passed. I'll give you a simple example, dear friends. To our bungalow, we have a fencing made up of wires, iron wires coated by zinc. One line, below that another fencing wire, below that the third one, the fourth one, fifth one, isn't it? There are rows, first, second, third, fourth, fifth. Fencing wires are like this, isn't it? Made up of iron, which are coated by zinc. Now, when you are standing over there and when you are throwing the marbles through that fence many times, or you are throwing the stones through those small stones or pebbles or marbles, you are throwing through this fencing wires, you find that most of the marbles they easily pass through that, indicating that between the fencing layers most of the part is empty. When the marbles pass easily or when most of the marbles pass easily indicates that most of the part between these two fencing wires is empty. In the same way, when most of the particles they pass easily, which particles? Alpha particles, that is the positively charged particles. When they pass easily through the atom, it clearly indicates that most of the part is empty. Few of the alpha particles, they were slightly deflected, indicating that the point through which they were deflecting, that must be a positively charged point. And some of them were clearly rebounded back, again back, indicating that at the center there is a dense part. Why they are rebounded? They strike, it's hard, this part is hard, so they strike back again, they rebound back again. If this was not hard, they will pass it and move ahead. But as it is hard, they are rebounded back. So this part in the nucleus is hard. Okay, these are the positive particles and these are rebounded. That means this part is also positive. This part is also positive, indicating that at the nucleus or the nucleus at the center is positively charged. There must be something positive inside over here. This was about the experiment carried out by Sir Rutherford, indicating that the nucleus or atom consists of central positive part called as the nucleus, Now friends, we are going to start with today the discovery of protons, Now, before we move ahead towards proton, we are going to see some concepts in this discovery of protons. So, one of the concepts in this discovery of protons is the hydrogen and the hydrogen nuclei. So, you all know that hydrogen is an element. Now, what is this hydrogen nuclei? Firstly, let us see this. So, this hydrogen, the atomic number is 1. That means it consists of 1 proton and 1 neutron. Sorry, it consists of 1 proton and 1 electron. 1 proton and 1 electron. And it does not have any neutron. This hydrogen 1H1. Hydrogen 1H1. 1 is the atomic number and the upper one is the mass number. The lower one is atomic number. The upper one is atomic mass number. We are going to see this atomic number and mass number in the further part of this chapter itself. So do not keep this as a difficulty, sir. I did not understood what is atomic number and mass number. In this chapter itself, we are going to study this. So this hydrogen consists of 1 proton and 1 electron. Protons are present inside this nucleus and electron is present outside. So this hydrogen consists of 1 proton inside the nucleus, 1 proton inside the nucleus and 1 electron revolving around. Okay, so what is this hydrogen? So you have understood what is hydrogen, an element with 1 proton and 1 electron, and it does not have any neutron. And now what is this hydrogen nuclei? So see this nucleus of hydrogen. This nucleus of hydrogen consists of only 1 proton. Is there any neutron? No, it consists of only 1 proton. And it is also called as hydrogen nuclei. This is the hydrogen nuclei. And what does the hydrogen nuclei itself mean? It means that you should have 1 proton inside. You should have, or it must have 1 proton. So anything that has 1 proton, a single proton inside, is your hydrogen nuclei, isn't it? Because only hydrogen nuclei has 1 proton inside. So hydrogen nuclei means what? It has 1 proton inside. Okay. So hydrogen, an element which has 1 proton inside the nucleus and 1 electron revolving. That is hydrogen atom. And hydrogen nuclei means the inner part which consists of 1 proton. Surely. Very nice, students. Good. So these two concepts we are going to use for the discovery of protons. So we have seen the discharge tube, and this discharge tube was taken by the scientist Goldstein, Goldstein, and E. Goldstein found that when the discharge tube is used and connected to the different poles of the battery, that is a positive and negative pole of the battery, he found that from the anode, particles are given out, a beam of rays is given out which travels towards the cathode. These rays are traveling from the anode to the cathode, and behind cathode a red glow is seen. But as they were traveling from anode to cathode, that means these are positively charged particles, but he was not able to prove that so. He could not reach up to that point. Okay, because every time science, we always move step by step ahead. All the results do not come at one time itself. So what he did, by carrying out the experiment, he found that these anode rays, they were traveling towards the cathode. Cathode is connected to the negative terminal. That means cathode is connected to the negative terminal. It has a negative charge. So which particles will be attracted? Positive particles. Positive particles will be attracted. So he found that the positive particles which emerge from the anode, which are emerging from the anode, this is my anode moving part, okay? So these anode particles are moving in a straight line towards the cathode. Cathode is negative charge. So that means positive particles are moving towards negatively charged particles. But he could not prove it that so. What are these particles called? How could be the nature? That so. He did not prove so much. Okay. So what happened is, we have seen just the gold foil experiment. Scientist Rutherford, he found that Rutherford said that at the center there is a positive part called as the nucleus in the atom. In every atom, central part is positive called as the nucleus. This was said by scientist Rutherford. Now, let us take our concept again. Goldstein, what he said? Some positively charged particles are moving. Rutherford says that at the central, there is some positively charged particles present. Now, what Rutherford did? Now, Rutherford found out that one element can be changed into another element by bombarding it with an alpha particle. One element, higher elements mostly, uranium, all this, when they are bombarded with alpha particles, they can be converted into another element. And during this experiment of conversion, they found that hydrogen nuclei are given out. Hydrogen nuclei is given out. So hydrogen nuclei is given out means what? We have seen what is hydrogen nuclei. This hydrogen nuclei is nothing but positively charged mass. Positively charged mass. And so he found that when an element is bombarded with alpha particles and converted into another element some positively charged particles were given out. Positively charged particles were given out, and he called them as hydrogen nuclei because they were having one positive charge. And so he called them as a hydrogen nuclei. And what does the hydrogen nuclei consist? Only one proton. So when it was bombarded, hydrogen nuclei was given out. That means protons were given out. And in this way, hydrogen nuclei, proton, all these were coiled together, studied together, and now the particles which were given out, that is the positively charged particles, he called them as the protons because they consist of only one positive charge which is equal to the hydrogen nuclei which consist of only one positive charge. He used the term proton to that one positive charge. He called it as a proton. One positive charge means one proton, and in this way the term proton came into existence. And again, studying the work of Goldstein, it was done further. The positively charged particles which were given out, now they were said as protons. They were called as protons. And so the discovery of protons is totally given, or the credit of it is totally given to Sir Rutherford. Is it clear? So this was about the discovery of protons. Now, dear friends, till now, we have seen that the electrons were discovered. They were attracted towards the positively plate or positive plate, and the electrons were discovered. Then the gold foil experiment proved that at the center there is a dense part of the atom called as the nucleus, which consists of positive part. That means consisting of protons, and which also helped for the discovery of protons. So electrons, nucleus, and protons are discovered. Now what is remaining is only the neutrons. What is remaining is only the neutrons. Now what happened? Scientists at the end of the 20th century, they established a relation that they found out that atom is neutral and it consists of protons at the center and the electrons revolving around it. Protons at the center, that is in the nucleus, and electrons revolving around it. And that was why the atom is neutral. Why? It consists of same number of electrons and protons. The atom is neutral. Now, after saying it that the atom is neutral, consists of same number of electrons and protons. Electrons are revolving, electrons and protons is same, and the charge on them is opposite. Protons consist of positive charge, electrons consist of negative charge. So number of protons and electrons is always same in an atom. 20 protons, 20 electrons. 20 positive charges, 20 negative charges. So it is neutral. Now they were looking upon the next concept of this atom, that is mass. That is the mass. Now during their study they found that the electrons which are revolving, these electrons do not have mass. They are negligible. What is negligible? No need to consider. Negligible? No need to consider. So they found that the mass of an atom is present in the nucleus, is present in the nucleus. Why? These electrons which are revolving around, they do not have any mass, or the mass is very negligible. No need to consider it. Only consider the mass of these protons. Okay, because they did not knew that neutrons are present inside. They only knew that electrons and protons are present, and the mass of electrons is negligible. So where is the complete mass of an atom present? In the nucleus, right? In the nucleus. And what is the mass? The mass is equal to the number of protons. The mass of an atom was equal to the mass of protons. So if there are 20 protons, the mass will be equal to 20 units. If there are 5 protons, the mass will be equal to 5 units. Now, this scenario was clear for the scientist. Now, when they were working ahead, when these scientists were working ahead, they found that the entire mass of an atom is present in the center. It is present in the center, that is the nucleus. This was clear to them. But their further experiments found that they were thinking that 5 protons are present. So the mass should be 5 units. But they found that that is 10 units. The mass is 10 units. For an element, they found that, or they thought that, or it is clear that there were 10 protons present. So the mass will be 10 units. But it was found that the mass is 20 units, double every time. When they were carrying out the experiment, they knew that this atom consists of 20 protons, but the mass was double, 40. So that means it was very clear from this experiment that in the center there is something which has the mass nearly equal to the mass of protons, which is having the mass nearly equal to the mass of protons. There is something present in the nucleus. There is something present inside the nucleus having mass almost double. That is having mass equal to the mass of protons, and the total mass is almost double. And this promoted Rutherford to predict the presence of another subatomic particle or another particle inside this nucleus, which has a mass nearly equal to the mass of that proton, mass nearly equal to that of proton, isn't it? And when this, see, when this nucleus was bombarded by the positive plate, it was reflected. This nucleus is having positive charge. So the neutrons which are present inside, the mass of these neutrons is equal to the mass of protons, but the charge on them will be therefore neutral. Why? Protons are having positive charge. We are bombarding something, and these positively charged particles are deflected. That means protons are present. Neutrons are also present with a mass same as that of protons, but they are not having any charge. They are not having any charge. And this proved the presence of neutrons. This proved the presence of neutron, that there is something. But now it should have some experimental proof also. It should have some experimental proof also. So let us see the experimental proof for this, friends. Now see, what did the scientist Rutherford did? He found that there is something now present, a nucleus consisting of protons and also some other subparticles. There must be some other particles. He did not name it, but he found that there must be some other particles which is having a mass exactly like that of the protons, but charge, no, no any charge. And so this work, that there is something, that particle was known, it was not named. Some of the properties were known. So that work was carried ahead by Frederick and Juliet Curie, and what they did, they took a beryllium plate. They took a beryllium plate and they bombarded it with alpha particles. This beryllium plate was bombarded with the alpha particles. Okay. And now they found that the beryllium plate again emitted some rays. This beryllium plate gave out some rays, and these rays were bombarded on a paraffin. That is your wax. They're bombarded on a paraffin, and they found that this paraffin or the block of paraffin gave out large number of protons, gave out large number of protons. Now it is very clear. See, friends, when this beryllium is giving out some plates, when this beryllium is giving out some particles, we do not know which particles are these, but these particles, when bombarded on paraffin, give out protons. So let us see the nature of these particles given out by beryllium. Can you see the blue rays denoted by N? When these blue rays are bombarded on paraffin, this paraffin gives out proton. So see the nature of these blue rays. These blue rays are so powerful that when bombarded on paraffin, paraffin gives out some rays. See the nature of these blue rays, how powerful they are. And so they must be having some mass. How powerful, how mass, heavy. So when they are bombarded, these blue rays, when they are bombarded on this paraffin wax is giving out some particles. That means these particles given out by beryllium, they must be having some mass, they must be heavy. And so when they are bombarding the paraffin, this paraffin is giving out something. And so these particles which were bombarded on paraffin, they must be having a mass, and scientists proved that these particles are neutral. They were not deflected towards positive or they were not deflected towards the negative plate. That means they are neutral. But when they give out something through the paraffin, that means they are heavy. They are heavy, indicating the presence of neutrons, And how are these neutrons? They are having mass similar to that of proton, nearly similar to that of protons, and scientists called them as neutrons. So it was named as neutrons by scientist James Chadwick. So electrons consist of negatively charged particles. Electrons are the negatively charged particles. Their mass is 9.1 into 10 raised to minus 28. Very, very negligible, very, very less. Protons consist of 1 unit positive charge, and mass is 1.6 into 10 raised to minus 24. Neutrons, they do not have any charge, but mass is same as like that of the protons, that is 1.6 into 10 raised to minus 24. So friends, this was all about the discovery of nucleus, electrons, protons, and neutrons. Neutrons are also the heavy particles, no charge but heavy. They are able, see here, why heavy? See, they are able to eject, they are able to give out the protons from this paraffin. How strong they are with respect to mass. And this Geiger counter is nothing but an instrument used to measure these alpha particles. Okay, so this is all about the discovery of the nucleus and the three particles present inside the atom. So this was, friends, the first video of today. I'm going to share one more video. We are going to see the next part in that related to the different models of atom. What does atom consist of? How are the protons, electrons, and neutrons present? How they move, how the electrons move. We are going to see it in the next video. So one request, one of all of you, once again, a short break, drink water. You can have chota breakfast again. Yeah, a small breakfast is enough for you. I'll be giving you a break of 4-5 minutes. In that you can have a little bit of water, chota breakfast, relax a little bit, sit silently, keep up your difficulties in one section of your notebook so that we can share them. It will be good for all of us, and moreover, be relaxed. Is that clear? So we'll be again back with the second video. Okay. Bye bye students. Just have a little short break and join back again. Thank you. Thank you everyone. Yes. Thank you dear friends.